Okay, so we'll start off with kind of the concept behind this. What we want to do is, with an angle, sometimes you're not given a nice pretty thing that's limited to the unit circle. So what do we do if we're just given an ordered pair or something out in the middle of nowhere that we want to figure out our trig function for? So basically what we do is we turn this into a right triangle. So if we do that, then we have our x value and our y value become sides of our triangle. And then if I turn this into any size, if I turn this into a circle like we did our unit circle, my circle became kind of ridiculous looking, then our hypotenuse would equal whatever the radius of that circle would be. So then it's sort of the same thing as our unit circle. It's just whatever the radius would become. So then we could redefine our trig functions based on our coordinate grid. So using this, my sine would become, opposite would be the y value of the ordered pair over the hypotenuse, which would be kind of like the radius or the distance between the origin and that ordered pair. We did the exact same thing with the unit circle. We just left out that radius because the radius was 1. So we were just simplifying with the unit circle. But we use this exact same definition with the unit circle. Well, the radius, to calculate it, what would I do? Yeah. Okay, so cosine, what would my definition of cosine be? Yeah, x over r. Now tangent, luckily tangent doesn't even depend on where you are. Tangent, you're going to have the exact same definition we had before. What's tangent? Y over x. And then again, with our new ones that we had, cosecant is just a reciprocal of sine. So it would be r over y. Secant would be r over x. And again, cotangent doesn't even matter with that, so it would be y over x. So let me go ahead, since I already have kind of an example here, let's go ahead and calculate these. So if I go and I find my radius, that would be 5 squared plus 12 squared equals r squared. So then it's just a matter of pulling out the numbers. Sine would be 12 over 13. Cosine would be 5/13. Tangent would be 12 fifths. These would just be the reciprocal of the ones I just found. So this would be 13/12. 13/5, 5/12. The hypotenuse is just the radius.
Okay.
Okay, now that works great for the first quadrant. The problem is for the other quadrants. So, what happens with here? How do I make that triangle for that angle? Okay. I can do this. However, is that the triangle for that angle? No. However, I mean, is there even a possible way to make a triangle for that angle? No. Okay, so what we have is we have something called reference angles. A reference angle is this angle right in here. All right, first of all, whenever we do reference angles, reference angles are always positive. So even though that one looks negative, we always consider it to be positive. The way we get a reference angle is we always take the angle and we go to the x-axis. So wherever we can, we just drop to the x-axis as close as we can. So it always creates a first quadrant angle. So we're always creating an angle from the first quadrant that's less than 90 degrees. Now, what happens, I think I threw away my unit circle every single day that I created it. But if you look back at your unit circle, what happens is whenever you're doing your trig functions, if I'm doing sine, the y value doesn't change no matter which way I'm looking at it. Hello? Hey. Yep, no problem. Bye. All right, Carter, that was for you. Here you go. Okay. If you look, if I do sine of 30 degrees, remember no matter where I was on the unit circle, the y value for 30 degrees was the same. All I changed was the sine. If I did cosine of 60 degrees, no matter where I was on the unit circle, the x value for 60 degrees was the same. All I changed was the sine. So that's how we use reference angles. When we relate it back to the first quadrant angle, we know that our values will be correct. All we have to do is change the sign to what we want it to be. So, we use these to get the correct value. Then we manipulate the sign. So what I'm doing with this is I'm creating this triangle because, again, I can't have triangles with negative values. So with that, I can figure out that my radius thank you. So my radius is 2 radical 5. Which numbers? That would be given to you in a problem. So now if I wanted to find my trig function, sine of theta. Okay, so sine is the y value and the hypotenuse. Since I'm in this quadrant, it has to be negative. Would be that. Now, this is overusing reference angles a bit. We're using this to introduce reference angles. I realize that a lot of this can be done without really using the reference angles, but reference angles are going to become more and more important as we go. Oh, sorry. That should be a 5 down there.
So isn't it this? Wait, how is the two square root of negative?
How is the what?
How is the 2 square root of negative? The next one?
This one?
The one
Okay, so I move the square root of 5 to the top, which leaves a 5 on the bottom. Okay, so that becomes a 10. The negative sign was already there because of the negative 2. Okay, then I cancel out a 2, which I was writing and talking at the same time, and I left a 2 down there instead of the 5.
So essentially it's just subtracting whatever larger angle we have from 180 to 360 degrees.
Yes. So, yes, mathematically to get the reference, yeah. What?
Is the hypotenuse equal to the radius, right?
Yes.
Then why should we find the radius of it? We already have that line.
Probably have what line there?
You already have that hypotenuse.
Well, I had to find one. I had to find it. I didn't know it beforehand, so I had to find it. So then I would know that this is this, right? Yeah. I don't feel like I answered your question.
No, you did.
Okay. Okay, so we could go through and fill out the rest of them. Like I said, I want to introduce what reference angles are. This is kind of an oversimplification of using them, but this also kind of shows you how we can use this with the triangle and how the definition still works. So anyway, wherever you do this, you can still use the Pythagorean theorem to find this, and you can still use your y and your x values. Okay. So finding sine of alpha is the exact same as finding sine of theta. They would have different signs, because since we're making a reference angle, alpha would be positive. So they don't actually have a coterminal, because alpha would actually be up above, because the reference angle would actually be a positive angle. Yeah. Yeah, no, you would be asked to find them all. To save time, I'm not going to write them all down. Okay, so sines and quadrants, just to make sure we're all on the same page with this. What would be the sign of sine of theta in this quadrant? Would sine be positive or negative in this quadrant? Positive. Because the y value is positive. Remember, r is a distance, radius is a distance, so radius never takes on a sign. So really you're just looking at the sign of the x or the y. So cosine would be what? Positive also, because the x is positive. So tangent, positive. And I'm not going to go through the others because the others would match up. Cosecant always matches up with sine. Secant always matches up with cosine. Cotangent always matches up with tangent. All right, so over here, sine would be what? Positive, because the y value is still positive. Cosine would be negative. So what would tangent be? Negative. Because if I take positive divided by negative, I get negative. Okay, so down here in this quadrant, quadrant 3, cosine and tangent, positive. Because negative divided by negative will give you positive. Okay, and last quadrant, quadrant 4, sine would be negative, cosine, tangent. So whenever you're doing your work, that's a good way of double checking if you have your answers correct. If you're working with an angle in this quadrant and you're getting positive answers, you know you're doing something wrong. All right, so 2 more examples, just things in the book. So you have some problems like that. Find cosine of theta if cosecant of theta is -3 and cotangent of theta is positive. Okay, I'm going to use a reference angle. So first of all, doesn't matter how I draw my triangle if we're dealing with reference angles. Cosecant deals with y values, right? Cosecant is r over y. So what's my radius? Except for radius can never be negative. So it's 3. So what's my y value? -1. Now, if cotangent is positive, does that mean my x value is positive or negative? So cotangent is equal to x over y. So I know that my y value is negative. So in order for cotangent to be positive, is my x value positive or negative? Negative. That makes sense? So that's why they're giving you this, so you can figure out the sign of your x value. Huh? Cosecant is r over y. So since this is -3, that means that this has to be 3. This always has to be positive, so that means that this has to be a -1. Yeah. What? Yes. So that means this has to be negative. Because cotangent is positive. Cotangent is x over y. We know that y is -1. So in order for this to be positive, that means that this x value up here has to be a negative value. So we have to do a lot of kind of thinking through our problem before we even find out all our numbers. So now I can put this into Pythagorean theorem. X squared equals, or x squared plus -1 squared has to equal 3 squared. So x squared plus 1 equals 9. So x squared equals 8. So x is going to equal 2 radical 2. But I know that that has to be a negative. So that means cosine of theta is going to equal x over r, which is -2 radical 2 over 3. So you see why I went through that type of problem with you? Yeah. Why is what? Why is what negative? Because we said that x has to be negative. The cotangent has to be positive. The cotangent is the division of x and y. If y is negative, okay, so does this make sense? You're going to have several problems like this. So, yeah.
How did you get all that information from? How do you just make natural the cotangent is bigger than 0?
Okay, how did I get this? I mean, this is the definition of cotangent. Okay, I knew this from here. Okay, so then I figured this out from this information. So cotangent is greater than 0. I know this. So in order for this to be positive, I have to have a negative divided by negative. So I used all that information to figure this out.
Okay.
Yeah.
I was supposed to know which ones to use. Because there's like some different definitions for each one.
Depending on your situation. It's whichever one works for your situation. So you have to have all three of them in your head looking at your situation. And multiple ones of them work. I mean, right here I created a triangle. after I create my triangle, I can use opposite over hypotenuse. Or I can use x and y because in my head I'm thinking, I have a coordinate system. It really doesn't matter.
So it doesn't matter which one you use?
No, because they're all really the same thing.
So we just basically have to remember like one set of them and do all of them? Alright.
But again, if you're working on coordinate grid, you have to remember that really y and x, whenever you're thinking about putting a triangle on your coordinate grid, what is x and y on your triangle? Well, x on your triangle is the adjacent side, y is the opposite side. That's where we get the definitions with the x's and the y's.
Yeah.
They're all really the same definition. No.
There's just too many of them.
No, and it's going to get worse.
Wait, so on our final, there's some like April magic, are we gonna get like a piece of paper?
Yeah.
Again?
Yeah, for your final.
The best thing to do is to draw the units with them first.
Always.
That can help you.
Okay. Find two possible solutions in degrees and in radians for cosine theta equals 1/2. Now, this is kind of leading up to something we're going to do in the next chapter, but we can already do this. This is good practice. Now, this kind of goes back to your unit circle, so if you have that in front of you, that'll be good. I don't, so I have to use my head, but I'll kind of draw it out for you a little bit as we go. All right, the problem is we're finding the angle from the value. Okay. Now, there are actually infinite possibilities, but there's only two possibilities whenever they limit us to one time around the circle, 0 to 360. Okay, where on your unit circle does cosine, so the x value, equal 1/2?
Degrees.
60 degrees and
Pi over 3.
okay, give it to me. So what we're doing is going around your unit circle, and let me put one up here real quick. So what we're doing is going around your unit circle, and right here, and right here, so you'd be looking at all these ordered pairs and saying, okay, cosine are the x values. Where on my unit circle do the x values equal 1/2? Well, okay, right here I have a 1/2. Well, right here this is pi over 3 and 60 degrees. So there's one set of angles where the cosine equals 1/2. Okay, so where else? So you go searching through the rest of your angles. Well, here's another place. So this is 5 pi over 3 and 300 degrees. So those are my two solutions where cosine equals 1/2. So that's kind of going backwards. That's what the inverse cosine does. The cosine with the -1 on your calculator, which we're going to talk more about in the next chapter. But this is a simple way of using your unit circle to do that is. So you're going to have some problems that ask you to do that. All right, so you understand how we do that? Good with it? All right, so Whenever I ask you to find a reference angle, if you're having problems with that, it will help you to draw it out. So draw out the angle and then find this reference angle.